It's good to see all of y'all. Let's see if I can manage not to lift this up and violate all kinds of FERPA regulations. This is our third test set of scores. Very similar to the first and the second ones. First test, second test, third test. Average was 87, and the number of people that took it was 32. I still have to record one grade, and I have one student with work issue that hasn't taken it, so change a teeny weeny bit from that. I did come to realize that if this were not a multiple choice test class, that the grades would not be this high. I know that you guys are following patterns, and hey, there's nothing wrong with learning as a human being that there are patterns to be followed, and you can, make some sense of that, and using the multiple choice format to your advantage. So I know that if this were in a regular semester, we'd not be doing this fantastically. But hey, there's one thing in your favor. You'll pass algebra in the first time, and some of you probably would not have had it not been for coronavirus. But that's okay. That's I can live with that. Okay, where are we? We are finishing up 5.2 and doing 5.4 today. And then on Wednesday, we'll hit 5.5. 5.5 will need some graph paper, and I did not put that on this Google slide, but there is, of course, on other Google slides, I've got graph paper for you, and I know if you bought a pack of graph paper, you probably have a sheet left, so I will use graph paper on 5.5 on Wednesday. Chapter 6 is a fun chapter. Chapter 8 is an easy chapter. So we're on the downhill slide. Just stay with it. We're almost there. You guys are going to make it out of here. You're going to do fine. Okay, I'm going to get that sheet out of there. There we go. Bury that somewhere. Okay, let's look at 5.2. Get resituated here. That's good. You focus it. Okay. 5.2, linear systems. We're looking at two lines in three variables. So we're going to start out with three equations that are in the same three variables, XYZ and XYZ. And then we're going to march down on this blue side to two equations with the same two variables. So if we end up with YZ on our first keeper equation, we want to be sure we have YZ on our second keeper equation. You've got to make sure that when you eliminate, in this case, in the instance I'm giving you, we'd be eliminating X. If you eliminate X in the first pairing, you eliminate X in the second pairing also. So you want to work your way down to two equations in the same two variables. It could be X and Z. Make sure they're both XZ. Then you'll take those two equations and work that down to one equation in one variable. So you'll have, let's say, Y equals 10. Then you want to march back up to where there are two equations in the same two variables. One of those will be Y, and the other one will be another letter, let's say Z. So you'll plug your Y in, the Z. Then you'll be armed with two variables, and you'll march back up. So we'll march down to get to one, march back up to get answers for all X, Y, and Z. Okay, we had done one plug-in, and then we did one actual. So we have 4 more actuals to do in this section, and that's all there is in this section. So let me give you another grouping here. No problem, Rebecca. Good to see you. Let's see. Let's look at 3x plus 6y. Was the parking lot full this morning? Is that what caused you to be late? That's what usually causes people to be late. Although, after spring break, the parking lot is not full. Although y'all have done such an enormously wonderful job. I mean, this class has not diminished. Yeah, there you go. This class has not diminished in this semester. We have 30, we started with 40, and we will have 36 people. Let me make sure that number is right. Yeah, 34 people. So we have had, but I forgot about, we've got one that's at a funeral. So anyway, anyway, we have had very few dropouts, and y'all come to class every single time, and that is a huge chunk of why the grades are so good. Multiple choice helps too, doesn't it? Okay, 3x plus 6y minus 3z equals negative 15. 2x minus 5y plus 2z equals negative 3. And 4x minus 2y plus 4z equals 2. There's our three equations in the same three variables, xyz, xyz, xyz. We're going to get it down to two equations in the same two variables. The first thing we want to do is kind of look over the coefficients, 3, 2, 4, 6, negative 5, negative 2, negative 3, 2, 4. We just have to make a decision, and your decision might not be my decision, might not be the guy next to you's decision. It doesn't matter. It doesn't matter if you decide to get rid of x's or y's or z's. I could argue that it might be easier to get rid of y's because some of them are already negative. However, I just have found with students, having it front up here, the x's are easier to see and they're easier to deal with. So let's kill x's. What I'm going to do is look at these x's. I've got a 3, a 2, and a 4. I know that the 2 and the 4 can both be brought up to 4. This one already is 4. That one I can make be a negative 4. Remember, one needs to be positive, whatever it is, in this case 4. And this one needs to be brought up to a negative 4 in this case. But one will have to be positive and one will have to be negative. So let's go ahead and do that. Let's group those two, and I'm going to take them off to the side. I don't want to mess this up too much. So I'm just going to take it over here. 2x minus 5y, 2z equals negative 3, and 4x, 2y. Okay, so there they are. And I'm going to multiply this one times negative 2. So now I'll have a negative 4x, positive 10y, minus 4z equals a positive 6. You really got to watch those signs. Negative 2 times negative 3 is a positive 6. You mess up one thing here. Nothing here is difficult. Nothing here is going to be taxing to your math brain, but it is going to be taxing to your attention span brain. It's 4z equals 2. Okay, x's cancel out just like we'd planned to have happen. 10y minus 2y, that gives us 8y. Oh, and look at there, a little Easter egg hiding for us to find. Negative 4z plus 4z, they're gone also. So this is a little bit strange. We are now down here with one equation and one variable. We've solved one of them. So in theory, we can now go back up to two equations in the same two variables. But we don't have two equations in the same two variables. We zoomed right down, straight down. We went from 3 equations. This is 3 equations in the same 3 variables. We started working toward this and landed here. So when we're talking about where these 3 lines cross, we've found our y number. I'm going to put y equals 1 right there. But we don't have a place now to take this in order to plug it in and find 2 equations in the same 2 variables and plug the y in. So we're going to proceed in the same way we would have proceeded. This gave us a gift, but I think sometimes gifts are kind of confusing sometimes, and this might be confusing to you because we haven't done enough of these. But that's okay. We're jumping into them. You're smart enough to figure this out. So keep working toward keep working toward exactly what we were doing. We had grouped these 2 together and eliminated x. Now let me group another 2 together and eliminate x. So I think I'll just grab these top 2. 3x. I'm just going to rewrite them. Okay, so I'm working toward eliminating x just as I did here. I got a 3 and a 2. I'm hoping that you know what number you need to bring both of these equations up to in order to have the x's eliminate each other. No, don't go down, go up. You want them to be bigger. You want to multiply. There you go. You want to make them both be 6. They've got to both be risen up. You're going to be multiplying to make them be that way, not dividing. Oh my gosh, dividing would be horrible because we'd have all kinds of fractions in here. You could do it. You could do it if you were just trying to kill yourself. So let's multiply this one to make him be 6. I'll multiply him times 2. And to make this one be 6, I'll multiply that one times 3. Now they'll both be 6x, and one of them needs to be negative. It doesn't matter. It doesn't matter at all. This game will be played either way. So I just picked this one. So let me multiply through, distribute through, negative 2 times 6, negative 2 times negative 3, and then negative 2 times negative 15. And then I'll multiply this through times 3. So x's are gone. And good, nobody else is going to die out here, so this will be useful to us. So remember, we're working on 2 equations in the same 2 variables. We got a gift here. We got one of our answers unexpectedly because 2 different variables dropped out. Deal with it the same way. Just keep plugging away. Find another equation. So we've got negative 27y plus 12z equals 21. There's a keeper equation. That's 21 right there. There's a keeper equation. And now, we don't have 2 equations in the same 2 variables, but once you get one equation, you're coming back up here to where there are 2 equations because you just need to plug it in. So here, we'll plug it in there. We don't actually need 2 when we go plugging things back in. We just need to take one of them. And since we only have this one, we're okay with that. Negative 27 times 1. Add 27 to both sides. And there we go. There's our another number. We've got z equals 4, so I'm going to put 4 in the z spot. And then once we have, coming back up here, once we've gone to 2 equations in the same 2 variables, now we're armed with 2 answers, and we can go up where there are 3 equations. So grab any of whichever equation looks less likely to bite you. Grab the first one every time if that's kind of the way you are. Do whatever you want to do. I think I'll grab this last one. So I got 4x minus 2 times y is a 1, plus 4 times z is a 4, equals 2, and then just work it out. None of the math will be too difficult for you. That's not what this section is about, for sure. Minus 14, so we get negative 12. So x is negative 3. So there's our answer, negative 3, 1, 4. Let's see. Okay, good. Just want to be sure I got it when I was practicing. Notice that they're nice, fat, healthy, whole numbers. That's what you're going to have each time. You're not going to have anything weird. If you get z equals 43 over 15, something went wrong. So you'll have nice, healthy, whole numbers. Okay, any questions on that one? Feel free to open up your mic. That might take you less time, make it easier on you. Okay, I don't see anybody with a problem. So let's go forward. Let's go to our next one. Let's look at negative 3x minus y, leave a space for the z, equals 7. Then y minus 2z equals negative 10. Notice I'm just columning them up. X minus 2y plus z equals 10. There's our system. Now, strictly speaking, it's not three equations in the same three variables. But I mean, if you were pushing it, you could say negative 3x minus y plus 0z equals 7. But this system has an x presence, y presence, and a z presence. So it is three equations in three variables. So our job is to knock it down to two equations in the same two variables. So we have got a gift. We don't have two gifts here, because even though this is in two variables and this one is in two variables, they're not in the same two variables. So we can accept one of them as a gift. I'll just take the top one. So I'm going to tell myself, there, I've got one equation in two variables. So I'm going to box that up. That's a keeper equation. There's one of them. I'm trying to get two equations in the same two variables. That means I've eliminated this one. That means I'm going to have to take those two. Let's see, what variable is eliminated here? I've got an x, I've got a y, I'm missing a z. So when I go to attack these two and combine them, I want to be eliminating z's. Whatever is eliminated here in your first keeper equation has to be the same variable. Because we're not going to be able to play the game if I've got an xy here and a yz. That doesn't give me anything. I need xy on the first. If I've got xy on the first one, I need xy on the second of the two equations. So let's go ahead and look if we're going to kill the z's. Oh, good. It's already, we've got a plus 1. You know, there's a 1 there. And a minus 2. So bringing them up, not down, bringing them up, we'll bring them both up to negative 2. That means I'm going to have to multiply this guy times 2. That'll give me a 2z right there. And when I add it to the negative 2z, that'll eliminate the z's, which is the game here. So let's see, I've got y minus 2z equals negative 10. And then let me distribute x here. Let me distribute 2. Minus 4y plus 2z equals 20, and the z's are gone. So we'll have a 2x minus 3y equals 10. There's our other keeper equation. Don't lose them. Notice that they're both in x, y format, and that's good because that's our next step, is to get two equations in the same two variables. So let's look at them. Now that we've got two equations in the same two variables, they're both x, y's, now we're ready to work our way down to one equation in one variable. And I'm hoping that, you know, those of you who are kind of getting the hang of it are taken off. And I know that that means that you run the risk of not eliminating the same variable that I'm going to choose. But if you're comfortable enough, it doesn't matter what variable, you know, it doesn't matter. We'll all get to the same answer. Okay, so in looking at these two, I'm looking at, I've got a negative 3 and a positive 2. Okay, and I've got a negative 1 and a negative 3. It would be easier to kill the y's because there's fewer things I have to do. Let me get them together so you can see that. So I know this is not, I've done a million of these, but you have not done a million of these. Here we go. There's the two keeper equations. If I'm trying to get rid of y's, this is already a negative 3. I just have to make this one be a positive 3, and that'd be a single step. But if I want to get rid of the x's, I'd have to bring them both up to 6. So I'd have to multiply this equation times 3 and that one times 2. So I think I'll take the easier route, and I'll kill the y's here by multiplying this equation times negative 3. That'll give me a positive 3y on the y and a negative 3y in the original equation. So let's see, 9x plus 3y equals negative 21. So I'm getting x equals negative 1. Let's see. So the x is negative 1. I've got one of my answers. Oh, this reminds me, on that multiple choice format that you have that is making life in this class a little bit easier, a lot easier, let's be honest. When we take this test, I'm going to have answers, A, B, C kind of answers. I might change those up. I'm trying to think about that. I might just give you one of them and not give you the other two, or give you two of them and not give you the third. I don't know. Either way, though, well, let's say I gave you all of them. Let's say that you have all three of the answers. Then you can plug in and see which one works in all three equations. So you don't need to do this work in order to find the answer. But I promise you that I'm going to go and look at your scratch paper like I did this time, like I've done all the times. And if you don't have this set up that gets you to the correct answer, I won't give you credit. So the multiple choice format will allow you to figure out, without doing all this, which answer is correct by just plugging them all in. But I will not give you credit, and I will take credit away if you have the right answer, but you have no scratch paper that shows me how you could possibly have gotten that answer this way. I mean, you've got to do it my way. You got to show me that you learned something in this class. You walked into the class knowing how to plug in numbers. I want to see that you learned how to solve three equations. Okay, so moving forward, x equals -1. Now that we've got one equation in one variable, we're working our way back up. Let's go to where two equations in the same two variables exist. That's either of these two keeper equations. It doesn't matter which one. I think I'll just grab this -3x minus y equals 7 and plug in my x equals -1. So -3 times -1. Got it done? Good, good, Rebecca. So we got 3 minus y equals 7. Be careful with that minus y. I know we looked at it on Wednesday, but I know students tend to drop that negative sometimes. When you bring that over, you'll have -y equals 4. So y equals -4. Oh, did you get 4? Did you? No, there's a negative there. Never mind. Never mind. So -4 there. And then we've got two of them solved. So let's go take these two up. Now see, you can't go to this equation because we need z, and this doesn't even have a z. So you would put a -1 in there, and you'd put a 4 in there, and you'd get 7. Big deal. We need to go to one of the equations that has a z in order to plug in our x and y and find a z. You don't have to use this one. We could use this one to be simpler. Y minus 2z equals -10, and just plug in the one fact that we've got, the -4. That makes life a little bit easier. You do it any way you want. Add 4, so we get -2z equals -6, I think. Oh, that might not be right. Let's see, -4 plus 4, -6, and I'm getting z equals 3. So z equals 3 there. Rebecca, what did we do wrong? And it might have been me. Yeah, I got 3 when I practiced it too. So check your math there. Okay, plugged into the big one. Let's see. So let's go ahead and take care of that and see what we can do here. Let's see, x, we've got x is -1 minus 2 times -4. That gives us +8. And then plus z equals 10. So 7 plus z equals 10. So z equals 3. So you just did some brain fart kind of stuff. Oh, okay, okay. See, and Rebecca got a whole number. So she would think she'd done it right because she didn't get something weird. But, you know, sometimes they work out wrong, still with whole numbers. Okay, so good practice. Always helps to, you know, making a mistake is not the worst thing in the world. It helps you to see something that you did wrong that you want to be sure not to do next time. All right, let's look at a word problem. You will have a word problem definitely in your homework, and I can't remember if I put it on the test or not. At a play production, so you are producing a play. 480 tickets were sold. If I'm giving you words, that means we're going to have to make up our 3 equations. And they are very formulaic. They are not super tricky. And I know you're not a fan of word problems, but don't be afraid of these too much. Okay, let's look at prices for these tickets. Were $8, $10, and $12. So cheap seats, expensive seats, and somewhere in between. The total income from sales of tickets, from ticket sales, was $4,500. And then the combined number of $8 and $10 tickets sold, the combined number of $8 and $10 tickets sold was 5 times the number of $12 tickets sold. Don't get sweaty about this. This is not rough. I know it looks rough. How many tickets of each type were sold? Okay, you're putting on a play. 480 tickets were sold. Prices were $8, $10, and $12. The total income from ticket sales was $4,500. And then the combined number of $8 and $10 tickets sold was 5 times the number of $12 tickets sold. How many tickets of each type were sold? Okay, let's get labels first, and the labels always come off of the question. How many tickets of each type were sold? You know we're going to deal in X, Y, and Z. So let's say X will be the cheap seats, $8 tickets. Now that's the number of pieces of paper. Picture what a ticket looks like. It's just, a little piece of paper, let's say. Y is going to be, so it's really the number of $8 tickets. Y will be the number of $10 tickets, because that's what they're asking us, how many tickets. And Z will represent the number of $12 tickets sold. So X, Y, and Z, the number, the pieces of paper that are purple, because those are the cheap seats. The number of pieces of paper that you will bring in that are orange or whatever. These are pieces of paper here. These don't represent money yet. So we need to make 3 sentences out of this because we've got 3 variables. The first one is going to be always super simple. They're telling you that Chloe, it's only going to be 8, 10, and 12 if that's the prices of the tickets. Is that what you're asking? I mean, okay, the tickets could be 14, 18, and $100 tickets, and then it would be the number of 14 and the number of 18 and the number of $100 tickets. So it's going to be some number of whatever the price of that ticket is. But these are all going to be pieces of paper. Keep that in mind. So the first equation that we look at is just talking about how many pieces of paper are there out there? How many seats in the theater? We got 480 seats that were sold. Let's say that's equals the number of the number of chairs in the theater. That'll make our life easier. So we know that the cheap seats, the purple tickets, plus the next group, plus the next group, that equals 480. That's the number of seats sold that are cheap, plus the medium-priced ones, plus the more expensive ones. That's 480 tickets. It's just the number of tickets, the number of tickets, the number of tickets. So it's a real super simple equation. X plus Y plus Z equals how many seats are we talking about? So when we're talking about the number of chairs, the number of tickets, the number of people, it's just X plus Y plus Z. Now let's talk about money. How much does each one of those tickets cost? Well, you know it costs $8. So each purple piece of paper, if we saw one purple piece of paper, it'd be $8. If we saw two, it'd be 2 times 8. If we see X, it's 8 times X. So if we start slapping money on all of these, it'll be 8X plus, we'll add in the medium price seats. Each one of those orange pieces of paper represents $10. So 10Y, and then each one of the Z ones, whatever color they are, will be 12Z. That's money. We're adding it to money. We're adding it to money. So it'll be the total amount of money that this earned. So the first equation will just be counting butts in seats. Certain number sitting on the front rows, a certain number sitting on the middle rows, and a certain number sitting way in the back will give us the number of chairs, the number of people we're expecting, the number of programs we better print, that kind of thing. Now let's look at money. So we're slapping on the dollar amounts for each one of those, and that's our total dollar amount. So total number of behinds, total number of money. And now we're going to have a funky sentence. The combined, you have to know what combined tells you to do, and I'm hoping you know that means to add. So the combined number of $8 and $10 tickets sold. So we're going to add up the $8 ones and the $10 ones. Now they're talking about the tickets, not the amount of money it made. So the combined number of the $8 tickets, that would be X plus Y. There's the combined number of the tickets, not the combined number of the amount of money sold, but the combined number of pieces of paper. So combined number of 8 and 10 is going to be X plus Y. Was means an equal sign. Let me put it over there where the equal sign goes. 5, let me put a 5, times, that means I'm going to multiply the number of $12 tickets. The number of $12 tickets is Z. So there are the 3 sentences. There's our system that we're going to be working with. You've got to be able to produce these 3 out of this mess. The first sentence will always be super easy. It's just how many butts do you have? Equal them up. Then we'll be slapping on some other feature, and in this case, money. Each one of these represents a contribution of $8 to the play, $10 to the play, $12 to the play. So money plus money plus money equals money. Tickets plus tickets plus tickets equals tickets. And then they'll have an unusual sentence here that you just take left to right. Combined number of $8 and $10 tickets, that's the purple ones plus the orange, was, that's an equal sign, that's a form of the verb to be, is, which is an equal sign, 5 times, multiply the number of $12 tickets sold. Okay, now we need X's lined up, Y's lined up, Z's lined up. Oh, move this guy over. He turns into minus 5Z, and now there's nobody over there. So put a 0. So now we have our 3 equations in 3 variables, and we want to narrow that down to 2 equations in 2 variables. I think I'll kill the X's. They're sitting out there in front waiting to be killed. Let's do these 2. That's going to be easy. Let's take the first one and the last one. And I'm going to multiply this bottom line times a -1. That'll kill the X's. So I'm going to scoot this first guy over here. And then I'm going to distribute -1 plus 5Z equals 0. X's are gone. That's excellent. That's exactly what I wanted to have happen. Oh, but just like in the previous problem, we've got sort of a gift. It's a gift as long as you know what to do with it. So the Y's are canceled. And we've only got 6Z equals 480. So Z equals 80. There's one of our answers. So we know here that 80 tickets were sold. 80 tickets. I just put a T there. That's not 80 plus or something like that. 80 tickets. Here we go. There. 80 tickets were sold of the $12 variety. Okay, once we have one of these, remember, we're not going to be able to go back up to two equations and two variables because we don't have two equations and two variables. So we're going to have to pair another of these original three together. Let's pair these two, the first one and the middle one. Okay, and remember, when we were playing with this one, we eliminated x. We also eliminated y, so it doesn't matter. I mean, don't listen to this if you've got plenty on your plate, but we can over here eliminate either x or y. We just need a situation where we've got z present, so we can plug it in and find one of these other guys. But since we're doing the ones in front, let's continue that. So I'm going to multiply times -8 there. Let's see, I'll throw it over here. And then 8 times 480, let's see, 8 times 8 is 64, carry the 6, 32, 38, 3840, and that's got a minus sign on it. X's are gone, that's excellent. 2y plus 4z equals, and then I know you can't read my writing, it's too squiggly there, but you probably got your own. And we're doing 4,500 minus 3,840, getting 660. Okay, I'm going to check that just to be sure. This 480 times 8, public math can be kind of a problem sometimes. Yeah, that looks good. Okay, so there's a keeper equation. We don't need two keeper equations because we got a gift. What we now need to do is just plug our z in there. So 2y plus 4 times 80 equals 660. Keep working that. $340, how about? So we get 170 there. So we've got, where is it? Up here, 170 tickets for Y, for the $10 tickets. And now that we are armed fully, we've got Z tickets, we've got Y tickets, now we can go up into any one of the three equations and three variables and plug that in. I think x plus y plus z equals 480 is just as easy as anything else. So x plus 170 plus 80 equals 480 tickets. Does that give us 250? So we get 230 out of that. So 230 cheap seats. I'm going to check my numbers. 80, 170. Yeah, good. Okay. I did it once before, got the same number, so maybe it'll be right that time too. Okay, so on this one, you had to start out by making your own sentences. They won't be difficult, but it would be difficult if you didn't have any idea what to do. It'll be structured so that what people want to do is they want to start slapping 8 onto X right off the bat. You don't want to do that. You want to just talk about seats first, then talk about money, and then use the third complicated sentence. All righty. Let's do a triangle problem. Did one on Wednesday. Let's see. Got something like that. Got X down here. Got Y up there and Z over on the right-hand side. Let's call this one 5X plus 5 up there, that angle. That's Z right there, and that side is 5X minus 5. Okay, so X is this little angle, Y is this angle, and his next door neighbor is 5X plus 5. Down here, Z is the interior of the triangle, and 5X minus 5 is the rest of his straight line. Okay, 3 variables, 3 equations. You know that the 3 inside the triangle equal 180, so x plus y plus z equals 180. And then from Wednesday, you know that these two lie on a flat line. So let's see. Let's go y plus 5x plus 5 equals 180. We got some work to do there. And down here, z plus 5x minus 5 equals 180. We've got work to do here too. We'll clean this up in a minute. But I want to get you're going to have to make up those 3 sentences. So the 3 angles of a triangle equal 180. And then 2 angles that lie on a flat line, on a straight line, they equal 180. So y plus 5x plus 5, and then z plus 5x minus 5. Okay, let's get this cleaned up. X plus y plus z is perfect. And now on this one, I've got 5x. I'm going to put it in the x column, 5x. I've got a y. I'm going to put it in the y column. There is no z. And then we want to move this 5 over that side to join the number. So that'll be a minus 5 over there, and we'll get 175. On this bottom line, we've got a z, so I'm going to put him here. Got a 5x, I'm going to put him there. And then this 5 needs to move over here. So there's our system. Okay. Here's again an instance where we've got a gift. We've got a keeper equation. It doesn't matter which one you keep. I think I'll keep this 5x plus y. 5x plus y equals 175. That's already in an equation with 2 variables, so that's going to be my keeper. Okay, now that really matters when you look at this. See what got eliminated. It's got an x and it's got a y. There is no z. That means when we go to create another keeper equation, we've got to eliminate z. So we're going to take the 2 equations that are left over, and we're going to have to eliminate z. And look, that's going to be fairly simple to do. Cool. So let me write these 2 equations. X plus y plus z equals 180, and 5x plus z equals 185. One of these equations needs to be multiplied times -1. I think I'll just grab the bottom one. It doesn't matter. We'll all end up at the same place. You rewrite, and then times -1 minus z equals -185. Z's are gone. -4x plus y equals -5. There's our other keeper equation. Right there. There are 2 keeper equations. Notice they're both in x and y, so we're in good shape. Okay, I'm going to have to move to another piece of paper. Let me see if I can't do that in a smart way here for you. I'm just going to do something like this for us. Okay, so here are our 2 equations. 5x plus y equals 175, and -4x plus y equals -5. We're down to 2 equations and 2 variables. You want to narrow that down to 1 equation in 1 variable. So grab one of these and multiply times -1. Doesn't matter. I'll grab the top one this time. Doesn't matter. So -5x. And then copy the bottom one. Gone. So there we go. We've got 20-degree angle for this little bitty angle right here. Let me write that in there. Got 20 degrees for that angle. And I did not notice on my math lab, my guess is they want x, y, and z. They don't care about 5x plus 5 and 5x minus 5. They don't want to know the size of all the angles. They just want to know x, y, and z. So let's go figure out y and z. We're going to have, now that we've got 1 equation and 1 variable, we're going to have to climb back up to the 2 keeper equations. Doesn't matter which one you grab. I think I'll just grab the 5x plus y equals 175 to figure out y. So 5 times 20 is 100. So y equals 75. So that one up there is a 75-degree angle. You can barely see. There we go. And then we're going to have to, armed with 2, now we can go back up to where there are 3 equations. Be careful, it's not going to do you any good to grab this one because you've got x and you've got y, but this one doesn't have a z either. This one you could grab. This would be the simpler one, or you could just grab the x, y, z. You could look at these. That's 95 degrees. That leaves you with 85 for this one. You don't have to do the geometry. You can do the math. So I'm going to grab the easy one. 5x plus z equals 185. 5 times x is 20. So z equals 85. Okay. Good times, yeah? Good times. Okay, we're done with 5.2. Let's look at 5.4. See, with this problem, this section, sorry, this next section, are we ready to go? Anybody, any questions? Anybody, anything? Holler if you got something. Open up your mic if you would like to, or print it in there. Okay. 5.4 is called nonlinear. We've been doing lines. Now we're going to do not lines. Systems in 2 variables. So we started with linear systems in 2 variables. Then we made this part more difficult. We did linear systems in 3 variables. Now we're making this part more difficult. Nonlinear systems in 2 variables. We won't go to 3 variables here. We'll stick with, this is the, we've made this part more difficult in 5.2. Now we're making this part more difficult. So these are interesting, but you can kind of keep a distance from them. We're not going to dive in too deeply. Let's look at our first little problem. First problem, x squared plus y, right there you say, well, that's not linear, equals 4, and 2x plus y equals 1. There's our system. This is a line. When you've got y to the first power and x to the first power, that's a line. So this one will be a line. This one, though, if we move the x squared over to the other side, we'll have y equals, I don't know why I wrote 4. We'll have y equals negative x squared. There's why I wrote a 4. We'll have that. We're not going to do that here, but we're going to do more in this section than you need for this section, but not more than you need for your brain. So let's look at what this is. Y equals x squared. You know what an x squared is. You know that's a parabola. And it's a minus, so it's going to be facing down. And this plus 4 is on the y part, not involved here. So this will be an upside down parabola up here at 4. So it's going to look something like that. That's what this first one will look like. This guy is a line. Let's make him look like a line. Move the 2x over so we have it in y equals mx plus b. You won't be having to do this. This is not what you're doing. This is me offering you a little bit better insight into what we're doing. So go to plus 1 right here. There's the y-intercept. Go down 2 and over 1. So this line is something like that. Notice where do the 2 lines cross? They're not lines now, but they're crossing right there and they're crossing right there. We're going to find those 2 places. If we were to take this out, we're not taking it out completely, but that's what this answer would be. Where does this parabola cross this line? So it's at 2 places. A parabola and a line don't have to cross each other at 2 places. We could have a parabola that does something like that and a line that does something like that, and they never cross. We don't know. We just don't know what's going to happen. But in this case, because I turned it around to something I can translate, and you can too, into a graph, we could see that they're going to cross at 2 places. Okay, let's keep working on this. What this is going to ask you to do in MyMathLab, what your first problem is going to say, is it's going to say, by substitution, you get x equals 3, and x equals -1. So they're going to tell you, they're going to solve this for you. They're going to solve part of it. They're going to tell you that when these two cross, they're going to cross at 3. You got to figure that one out. And they're going to cross at -1. You got to figure out the y. So they're going to get, and you don't need this picture in order to do that. What you need to be able to do is plug you need to plug stuff in. So what you got to do is be able to plug the x in and plug the -1 in. So we're going to have an answer that looks like that, and we're going to have an answer that looks like that. We just got to figure out the y there and figure out the y there. You can plug into either equation. I'm going to avoid the x squared just because I don't feel like messing with an x squared. Let's tackle this equation. Let's plug it into this equation. Because you know, once you get a variable, you get one variable in one equation, you then go back into the two equations in two variables, pick the one that looks less likely to bite you. So I'm going to use 2x plus y equals 1. That'll be 2 times 3. So 6 plus y equals 1. So y equals -5. So they're going to tell you by substitution you get x equals 3 and x equals -1. They're going to ask you to come up with what the y is in those cases. Let me do the same thing here. 2x plus y equals 1. Let me plug in the -1 that they've told me I could get. So y equals 3. So here are the two answers right here. When they give you the x equals 3, you plug in to find -5. When they give you the -1, you plug in to find 3. You could have used this equation. X squared, that's 9, plus y equals 4. Move the 9 over, and you get -5. X squared, that's 1. Move the 1 over, you get y equals 3. So it doesn't matter which equation you plug it into. Now, this you do not have to do, but notice -1, 3 is that place where the parabola crosses the line. And 3, -5, okay, my drawing's not perfect, but you get the idea. It's in that quadrant. That's the other place where they cross. And you can see my line should have come down further. Anyways, all of that is free information that ties into what stuff that you know from this class, or maybe you brought in with you in another class, from another class. But this is what you'll have to do right over here. They'll give you two equations. They're not both linear. This one's linear, it's a line. This one is not linear, it's parabolic. And they will give you the x's. You have to plug in to find the y's. Okay, let's look at number 2. Another nonlinear pair, 4x squared plus 3y squared equals 85, and 7x squared minus 2y squared equals 4. There's our nonlinear pairing. We have not looked at either of these when both are squares. But what I know about this is that this squaring here, when it's a plus sign in between, that's going to be a circle of some variety. That's going to be a circle. I'm just going to put it there. When you've got two squares with a minus between, it does something else. It does half circle there, half circle there. So it sort of ends up looking like a basketball. So you've got a half circle on the outside and a half circle on the outside. We're not going to get this in depth. You're only going to worry about the algebra. But you can see, where do these two systems cross, or where do these two equations cross? They cross at 4 places in this instance. You're not going to have to worry about that. We're not even going to get that far, I don't think. I think in this one, let's see, what is this one going to ask you? Okay, they're going to tell you, in this case, you want to eliminate x squared. They're going to tell you that. What do you multiply? What do you multiply the top? What do you multiply each equation? I wrote in shorthand on my notes, and that's not quite adequate. What do you multiply each equation times? Okay, so they will give you the system of nonlinear equations. You do not need to know that's what it looks like. but they're telling you to eliminate x squared, and they're asking you what are you going to multiply each of these times. It's a drop down on this one, so they're going to help you out somewhat. So they're going to ask you what you're going to multiply. Well, first off, what are we going to bring these two up to? If we're going to eliminate x squared, they're the x squareds. We got a 4 and we got a 7. Remember, you're bringing them up to 28, right? So we're going to bring them both up to 28. That'll be this one multiplied times 7, and the bottom equation will be multiplied times 4. One of those will need to be multiplied times a negative. And so, like on the first one, they'll give you choices, that drop down where you hit their little empty blank, you hit there, and you've got this long thing that drops down here. And your choices might be 3, 4, -7, and 8, something like that. Well, you would see, okay, needs to be a 7, and they've decided to put the negative on that one, so you would choose there. So they're deciding to put the negative there, which means that on the next drop down, you would not choose -4, you would choose the 4. So, I mean, you play with it, and I don't even know if -4 is a choice there. So, you figure it out, but they will slap a negative on one of them for you. Okay, that's all you're doing on that one, not going any further there. Let's look at number 3. Let's see, they got x squared plus 5y squared equals 7, and x squared plus y equals 2. Let's see if I can make that a little better experience for you. Let me take attendance again because it's been a while and I don't know if... Okay. Okay, let's see. This has an x squared and a y squared on it. And so that's going to be a circle because they're adding the two of them together. So we're going to have a circle here. Don't know where it is, but let's just slap it there for starters. This y equals -x squared plus 2. So that's a parabola facing down just like the number 1, but f at 2. So let's just say that's 2, whatever. So this is going to be something like that. That could happen where we have 2 crossings. It could also happen where we have 4 crossings, 1, 2, 3, 4. Or it could happen where we have no crossings. We've got a circle and a parabola and they don't cross at all. They don't care. They're not going to get as involved in that. But we've got a problem coming up that does require you to think like this. And so that's why I'm spending the time doing this. So let's see, number 3, let's see what the instruction is there. On number 3, they're going to say, multiply the second equation by what? Okay, so let me check my notes and see what they want out of you here. Okay, they must be telling you to eliminate x's. So they're going to ask you, what are you going to multiply the bottom equation times? We have an x squared there. We have an x squared there. So we want to multiply the bottom equation times -1 in this case. Then we'll have x squared plus 5y squared equals 7. And -x squared minus y equals -2. And the x squareds are gone. That's what you wanted to have happen. So then what do you have? Then you've got, be careful, this is not 5, these are not like terms. This is a y squared and this is a y term. So you're going to get 5y squared minus y equals 5 right there. That's what you're going to get. And that is all they want from you, I believe. Look at my notes again. Yeah, I think that's all they want from you. If you were to try this, 5y squared minus y minus 5 equals 0, that doesn't factor into 2 sets of parentheses nicely. So this would be a problem you would end up having to do with the quadratic equation, but that's not involved in what we're doing. So we're not asking you to go that far. Just what would you get? So watch out, those are not like terms. Now, you know you're going to get two answers here. So the situation for this circle and this parabola would be this one. This is an instance where a circle and a downward-facing parabola would intersect with two points of intersection, one right there and one right there. We're not finding them in this case, but we're going to look at that in a minute. So if they asked you, for instance, if a circle and a downward-facing parabola, a negative parabola, negative on the leading coefficient, intersected with two points of intersection, what would that look like? And that's what it would look like, something like that. Okay, let's go look at number 4. So, you know, I did a whole lot of blah, 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 blah on 1, 2, and 3. All this is extra. Number 1, they just asked you by substitute, they gave you half the answers, they want you to plug in. So number 1 is a plug-in problem, that's all. Plug into whichever equation, not both, just one of the equations. Number 2 was just, if you're going to eliminate the x's, what are you going to multiply the both of them by? And that's a drop down, that's as far as you go on that one. Number 3 is, if you were to eliminate the x squareds, what would you multiply the first equation times? Do it and see what you get. That's all. So this so far is a very simple algebraic section. Okay, let's look at actually factually doing one of these problems and see what happens. X squared plus 2y squared equals 1089, and x plus y equals 33. Okay, there's our system. This is a circle. It's got x squared and y squared with a plus sign between them. And this is a line. So lots of things could happen there. We've got a circle and we've got a line. And you can imagine the line could be straight above the circle. They'd never intersect. We could go zipping right through it and they could cross at two places. Let's see what's going to happen. We don't want to use elimination here because we'd have to multiply everybody times negative x. And then you'd have a negative x squared. That's going to be really awkward as we get over here and here with x's. So we'll use substitution here. That was back to 5.1. That's been a while. Let me remind you that you need x equals everything else or y equals everything else. So let's get, in this case, let's get y equals everything else. So I'm going to move the x over here. So I've got y equals 33 minus x. There's my substituting block right there. And I'm going to go put it into the other equation everywhere I find a y. You could have done the same thing with x equals and had 33 minus y. This problem will work out. Either way, it doesn't matter. So let's go up into this first equation, x squared, then a plus sign, then a 2, then a y. Y we know is 33 minus x, then we're squaring it, equals 1089. Okay, this is our problem now to solve. We've had two equations with two variables. Now we've narrowed it down to one equation with just one variable, and let's work it out. So we've got x squared plus 2. Let me FOIL that out. This is 33 minus x times 33 minus x, and we're going to FOIL it out. 33 times 33 is 1089. Yeah, it might be 1089. Let me just make sure. 33 squared, 1089. Okay, so 1089, not a coincidence. These problems are going to be made simpler for you by this happening. You'll see. Actually, that might not be true. Then we've got outside is a negative 33x, and then inside is another 33x, and then plus x squared. Okay, let's distribute. So x squared plus, it's going to give us 2178 minus 132x plus 2x squared equals 1089. Let's see, there's the equal sign. We've got 2x squared and 1x squared, so 3x squared Then we've got a minus 132x. And then may as well bring this over to join. So it's a minus 1089 with the 2178. So that'll be a plus 1089 equals 0. Okay. Let's see if we can factor out a 3. That would be lovely if we could do that. 3, you know, we'll factor out here. 3, 4, 5, 6. Add up the digits. 6 divides by 3, so I know that one will divide by 3. And then that's 18, and 18 will divide by 3. So let's pull the 3 out. X squared minus 44x plus 3, 2, 6. Nah. Public math. 1089 divided by 3, 363. Yeah, thank you. 363 equals 0. The 3 doesn't have a variable on him. Ditch him. He's gone. 3 equals 0. No, it doesn't, so we're not worried about that. Let's factor this. So we've got x and x. Signs need to be the same, and they'll need to be negative. Here's a gift to you, 363. Let's look at the square root of 363. 363. Oh, that didn't work. So we're looking for two numbers that multiply to give us 63 that are 44 apart. Okay, let's use it. 1 times 363, then 2 won't go in, 3 will go in, 121. That's not going to help us because they're not 44 apart. So we're going to have, let's see, 4, will 4 go in? No, no even number will go in because this is not an even number. 5, 6, I'm seeing 11. You know 121 is 11. So let's try 11 going in. 11 goes into 363, 33 times. Oh, looky there. Those will add to give us 44. So we've got an 11 and a 33. So x equals 11 and x equals 33. Okay. Pain in the rear. Now we've got to plug them in. We've got our two answers here. Let's plug it into this easier equation. X plus y equals 33. So 11 plus y equals 33, y equals 22. So there's one, 11, 22. And then plug it in over here. X plus y equals 33. So y equals 0. So 33, 0. There's the other place. Okay, so there are your answers, 11, 22, and 33, 0. It's all just algebra. It wasn't fun algebra. I do know that if you've plugged in x equals 33 minus x, that works out a whole lot easier. The math is just not as difficult. How can you know that? I don't know how you can know that, except that maybe you don't want to take your plug-in piece and multiply times 2. You'd rather take a plug-in piece and not multiply times 2, which is what you would have gotten had you said x equals 33 minus y. Either way, it's doable. Let's look. 1122 is, I'm going to make it on a small scale, somewhere up there. And then 33, 0 is there. Maybe that's not far enough. So this was a circle and a line. So it'd be something like the circle is doing that, and the line is doing that. Something like that. Yeah, that's not too bad. It says across at 33. So they're the two places where these two cross. You are not going to be responsible for that, except in the reverse. They're going to say to you, if you had a line with a negative slope and a circle, what could be the situation where you have two answers, where you have two solutions to where do they cross? So if they asked you, without, this is what you would match it to, a line and a circle with a negative slope, what would happen where they would cross twice, that kind of thing. Okay, what are we doing next? Number 5, okay? Let's look at number 5. How much time do we have? Okay, we're doing good. We won't finish this section, but boy, we're going to get close. Let's look at x squared plus y plus 10, squared equals 9. This is x squared and then a y squared when they're adding, so that's a circle. This does something different to it, and you don't need to worry about that for this class. And then x squared plus 3y equals negative 21. This would be a parabola because we could eventually get y equals, move this parabola over this negative x squared. So this is a parabola that's facing down, and this is a circle. And we're looking at what's happening with them. They're telling you to multiply the second equation times negative 1. So they will tell you, multiply the second equation by negative 1 and then finish the problem. So let's do that. Multiply this guy times negative 1. So we've got x squared plus y plus 10 squared equals 9. And then negative x squared minus 3y equals 21. Those two are gone. We're going to have to FOIL this out. So that's y plus 10 times y plus 10. We get that. So we put that down here, y squared, 20y plus 100. And then we've got minus 3y. I'm just going to put it there, equals, and then 9 plus 21 is 30. Okay, let's clean this up because we've got like terms right there and right there. So it gives us y squared plus 17y, and then may as well move over that 30 right now, plus 70 equals 0. So we've got y squared, then 20y minus 3y gives you 17y, and then you have 100 still on this side of the equal sign. Let's move the minus 30 over and we get a plus 70. Okay. Y and y, everybody's positive, so we got plus signs. We're looking for two numbers that multiply to give us 70, that add together to give us 17. So 7 and 10, 10 and 7 doesn't matter. So we're getting y equals negative 7 and y equals negative 10 when you set those equal to 0. Now we got to plug those in and figure out what's going on. Doesn't matter. Let's grab the first equation. So x squared plus negative 7 plus 10 squared equals 9. To check the y equals 7. So I put in the negative 7 right there. So I've got x squared plus 3 squared equals 9. That is 9. Move the 9 over. X squared equals 0. So x equals 0. So that was when y equals negative 7, x equals 0. So one of our points where these two figures cross is 0, negative 7. Do the same thing over here. X squared plus negative 10 plus 10 squared equals 9. That's 0. 0 squared is 0. So x squared equals 9. You put the radical on both sides, so x is 3 and x is negative 3. We got both positive and negative versions. So one of our points then is 3, negative 10, and another point is negative 3, negative 10. You got two x's here. Pair them both up with y equals negative 10. Okay, so remember this was a circle and a parabola. Let's see what we've got. 0, negative 7 is right there. 3, negative 10 is maybe right here. And negative 3, negative 10 is right there. So our circle and our parabola, right there, they cross at those three places. They intersect at those three places. Kind of weird. But you don't have to worry about that. You just have to worry about coming up with the algebra. Okay, then number 6 here. Number 6 says, graph what this would look like. Now, all that I went over on those first 5 problems is going to be useful on this problem. So you're supposed to choose the graph that gets described here. The system The system whose graphs are a line with a negative slope and a parabola whose equation has a positive leading coefficient. The positive leading coefficient. And has one solution. They're going to cross one time. Okay. The system whose graphs are a line with a negative slope. So we need a line with a negative slope. I'm hoping you know that that looks like that. Goes in a negative direction. And a parabola whose equation has a positive leading coefficient. So the other figure is a parabola whose equation has a positive leading coefficient. That means a positive parabola. That kind of parabola that points up, that opens up. And they have to cross at one place. So we need a line and a parabola that will cross at one place. If we put our parabola here and we want our line to cross only at one place, be careful. You put him up here, he's going to hit twice. You put him down here, he won't hit at all. You need to put him right in there, tangent to it, if you know that word. So this parabola and this line with a negative slope, the parabola that's positive and the line with a negative slope hits once. That's the picture you're looking for, something like that. It might be, you know, way down here, but still, they're hitting once. I've written a note to remind you what a line with zero slope looks like. If you're faced, and one of the problems has you creating a line with a zero slope, remember the slope tells you how difficult it is to climb. So a line with a zero slope is a flat line like that. Not up and down, that's an undefined. This is a zero slope. So know that little piece. Okay. We'll save the next two. So we've got 7 and 8 still to go, and there's no reason to rush through that because Wednesday's work is just a bunch of graphing, and it's very simple graphing. You'll enjoy that. So we'll save 7 and 8 here. Let me grab our calendar. Look at what we're doing so far. We have done 5, we finished up 5-2, and we did most of 5-4, 1 through 6 and 5-4. We'll finish those two problems up and do 5-5 on Wednesday. Okay, I think I'm done. If you've got anything, let us know, or stick around if you want to just talk to me about it. Otherwise, I will see you on Wednesday. Have a good couple of days.